So this is the Lesson 9 Part 2 video. Let's pick up right where we left off in the Part 1 of Lesson 9. We had just finished writing the circle of evaluation for this distance example, finding the distance between the points 0, 0, and 4, 3. So now that we have finished our circle of evaluation, down at the bottom we're asked to write this circle of evaluation in code. So this gets a little bit tricky because there are so many sets of parentheses. So instead of actually starting at the beginning of the line here, I'm actually going to start a little bit of the ways in, starting with line length 40, which is actually the innermost circle right in here. So I'm actually going to help you see how I'm formulating this answer in code, I'm actually going to color code the parentheses. So line length 40, and then that expression there needs to get squared. So using blue parentheses, I'm actually going to show that the line length 40 gets squared. So I'm using the SQR abbreviation for that. So that same code has to happen for these other inner circles. So my inner circle here, line length 30, needs to get written out. So line length 30, and then of course that needs to get squared. So I'm going to use a gray pen to show that that needs to get squared, which is SQR, with an open parentheses and a closed parentheses. So far I have my two innermost circles completed. Finding the line length between 4 and 0, and then squaring that, and then finding the line length between 3 and 0 and squaring that. Well, what happens in this circle of evaluation to those two circles, the blue circle and the gray circle? Well, they're actually being added together. So I'm going to put an addition function out front, and I'm going to use yellow parentheses to show that. So I'm going to highlight those parentheses in yellow to show that those were the parentheses for that circle of evaluation. And then finally we see that the square root is the main function that's occurring here. So that's going to go all the way out front with an open parentheses and a closed parentheses. I'm going to highlight that in blue to show you that the beginning parentheses and the end parentheses match up there. So we have a lot of parentheses here, but every single one of them is necessary. And the order of every single thing here is also incredibly important. None of the order can be changed. So that is our distance formula converted into a circle of evaluation and then converted into code. Let's take a look at how this is going to help us on the last page of the packet, which is actually where we're writing the distance function for our video game. So the directions here say write a function called distance, which takes 4 inputs, px, py, cx, and cy, where px is the x-coordinate of the player, py is the y-coordinate of the player, cx is the x-coordinate of another game character, and cy is the y-coordinate of another game character. So we find that the x, the px, the py, the cx, and the cy actually come from putting together the x or the y and then either player or character. So that's why those variables are supposed to make sense. What is the function supposed to do? It should return the distance between the two using the distance formula. So we're going to be using the code that we wrote on the previous page to help us here. So let's start with the contract. Function name is distance. For the domain, let's take a look at what the word problem says about the inputs. It first of all says that there are 4 inputs and they are all either x or y coordinates. So are those numbers, strings, images, or booleans? Those are actually all numbers. So we have 4 inputs and they're all numbers. So we have to repeat the word number 4 times. Number, 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 number. And for the range, it says what the function is supposed to do is it should return the distance between the two using the distance formula, which is going to be a number. Are they 5 pixels apart, or are they 70 pixels apart, or are they 400 pixels apart? The distance that this function actually finds will be a number. For the purpose statement, what does the function do? I would say the function finds the distance between two characters on the screen. So you can see my purpose statement written there. You may want to pause the video and copy that down into your packet. Otherwise, let's take a look at the examples and the definition. So the first example is completely done for you. The first example shows that if we want to find the distance between 100, 200 and 300, 400, what the computer is supposed to do is, starting in the innermost parentheses here, it's supposed to calculate the line length between 100 and 300 and then square it. And then this innermost parentheses over here, calculate the line length of 200 and 400 and square it. And then find the sum of those two things by adding them, and then finding the square root of the whole thing. So that's what we did on the previous page, where we converted the distance formula into code. I do want to point out here that the 100 and the 300 are the x coordinates. So you'll notice that when we do line length, we keep the two x coordinates together. We want to actually find the distance between the x coordinates separately from the y coordinates. So the two y values here are 200 and 400. Those are the two numbers that need to appear together for the line length function to calculate the distance between just the y's. So the first example is totally done for you. I'd like you to pause the video now and try to fill in all of the blanks for the second example based on what you see in the first example. Use that as a guide. So pause the video now, try the second example on your own. Here's exactly what your second example should look like. All of the functions are exactly the same, the squared, the addition, and the square root. I do want to point out that our y values, 150 and 600, should appear together in the first line length function, and our y values, 350 and 500, should appear in the other set of parentheses for line length. Those do have to go in those locations. So when we get to our definition, we were actually given the variables for our inputs, px, py, cx, and cy. So instead of using specific coordinates and specific numbers, those are the variables we use for our inputs. So we need to fill in the blanks here in the two sets of parentheses. So we have the square root, we have the sum, we have squared. What we need in here is the line length between which two of these inputs. Hopefully you're thinking px and cx. Those are the first and third inputs. Those are the two x coordinates. And for the second blank here, we need the line length function again, but this time we're using the two y coordinates for our inputs, py and cy, the player's y coordinate and the other character's y coordinate. So that concludes the two examples in the definition here for our distance function. So in addition to the contract and the purpose statement, we have finished our design recipe for the distance function. So you should be ready to finish up page 4 on your own by inserting this code into your video game, and make sure you get signed off at the bottom of page 4 to get credit. That's the end of this video.